Okay, in this question, we are given a graph that plots out the variation of net force with respect to time. But net force is equal to m times a. So actually it could be easier if you just think of this graph as acceleration time graph. So during this portion here, the acceleration is positive. So the car will start from rest to reach a certain velocity here. Because the acceleration is becoming smaller and smaller, that's why the rate of increase of velocity also becomes slower and slower. From this point onward, we actually have a negative acceleration, so the velocity is going to drop down, it's going to change towards a negative direction, so it may look something like this. And I know that the velocity will be back to zero here because these two areas is exactly the same. If you think in terms of acceleration, then this implies that the change in velocity here, or rather the increase in velocity here, matches the decrease in velocity here. That's why it's back to the original velocity. If you go along with the original graph, which actually shows net force, then the increase in momentum here matches the decrease in momentum here, which also means that the car will be back to zero velocity here. Okay, during this portion here, the acceleration is still negative, so the velocity will still be changing towards the negative direction. But because the acceleration is becoming smaller and smaller, the rate of decrease of the velocity also becomes slower and slower. From this point onwards, it's a positive acceleration, so velocity will change towards the positive direction, and this will be the graph. So the velocity actually increases from here to here, and then the car will slow down from here to here. It actually comes to rest here, and then it turns around and speeds up in the opposite direction. It actually reached the maximum speed in the negative direction here. From this point to this point, it's actually slowing down. Alright? So whether you speed up or slow down has got to do with your current velocity and the direction of the acceleration, whether it's in the same direction as the velocity or whether it's in the opposite direction. Let's start again. So during this portion of the graph, you actually start from rest with acceleration towards the right. So you start from rest, acceleration is towards the right, so you pick up velocity towards the right. Between this portion here, by the time you reach t is equal to 0.25 seconds, you'll be having a velocity that's towards the right already. And your acceleration is now in the negative direction, leftward. So you're currently traveling towards the right, your velocity is towards the right, but the acceleration is towards the left. That means you slow down. Alright? Slow down. Let me write it up here. This one speeds up. Okay, then at 0.50 second, we know that the car has slowed down to a complete stop here, instantaneously at rest here. And now the acceleration is towards the left. So you are going to pick up velocity towards the left, and you are going to speed up towards the left. At t is equal to 0.75, you will already be traveling towards the left with a certain velocity, and the acceleration is still negative, so the acceleration is also to the left. So if your velocity and acceleration are in the same direction, you will slow down. Get a picture? So whenever your velocity and acceleration are in the same direction, like here, or like here, then you will speed up. Whenever your velocity and your acceleration are in opposite direction, like here and here, then you will slow down. Okay? I hope I've made it clear. Ta-ta!